Hello folks, and welcome back to another exceedingly boring but yet somehow fun-packed episode on our old Model 3 drive unit PCB design. Now I know what you're thinking. You're probably thinking, what the hell, Damien? A year and a half passed with no updates at all, and now we've got 2 updates in 2 weeks. What's going to happen next? Will we have 3 updates in 3 weeks? Who's to say? The pace has accelerated somewhat, as I mentioned in the last episode, due to the fact that we have a very talented engineer assisting us with this project now. So, before we tear into the details of what's been done so far, and I must stress that Arthur has done all of this work himself. I'm in the role now more so of just a reporter on this level of progress that you see here. I've been very busy with the house over the last few weeks trying to get some work in before the rainy season starts, because we seem to have that now here. There's a rainy season. It takes about 9 months. Anyway, less about that. So, what I want to do before we delve into some of the details here on the PCB is I just want to pick up on some of the comments from the last video. I want to say thanks very much, by the way, for all the positive comments there. And this kind of ties into the first one that I want to address. So a very common question that I've had since when I started this project. This isn't the first video on it. This is by no means you know, the first go at this. So for people that are genuinely interested, I would recommend first of all check out the playlist of all of these videos. Secondly, check out the links in the description to GitHub. You'll see the repositories there, both for the hardware project that we're discussing here, and also for the software project for the existing TI microcontroller. So, first question that I get is, sorry, the most common one I get is, why am I not just using Tesla's existing firmware on the TI micro in some variant, hacking that in some way and controlling the drive unit via CAN in the way that it is in the Model 3. So to answer that properly would probably take hours, but I'll try to condense it down to a couple of minutes for you. So the first and most obvious reason for that is that other people have already done that quite successfully and have built products around it, and to the best of my knowledge works just fine. So for me to tackle that again from the ground up would be just a big exercise in reinventing the wheel. So I'm not going to do that when an existing solution exists with that option. Second thing is, and this is where it gets a little bit more complicated, all of the projects that I work on with electric vehicles in particular have the aim of not just being something that only a few people can manage or that a few people can do. So basically closed source systems that by their nature have to stay within a very tight group of people, and there's various reasons for that. Again, that's none of my business. What I prefer to do when I approach a project is to make that solution, whatever it may be it hardware, software, or increasingly these days a combination of both, to be as free and open as possible. And the main aim of that is that if something happens to me, if something happens to the people that I'm currently working with, for whatever reason, they no longer wish to become or to be involved with it, that the people that have invested in it, that have it running in their vehicles, can actually maintain it, because you've got schematics, you've got building materials, you've got board layouts, you've got source code, you've got everything that you or someone that you may know or employ to assist you further down the road, pardon the pun, should you run into a problem. I guess a lesser part of it for me is that I have this foolish rose-tinted glasses idea that if I make something open and available, it will attract more people into it who will collaborate on it and make it better, and we can all sing Kumbaya and dance around the campfire. And that works in about 0.0001% of the time. But when it does, it works really well. Case in point here, we now have Arthur on board with the Model 3 PCB project. So I won't get into any more details on that in this episode, because it would just tie it all up in me going into a rant and this kind of thing. But suffice it to say, as I said in the last episode, I believe that not only do you have a right to repair the thing, you have a right to understand how it works. And if it's not for you to understand that, if that's not your thing, if you have a problem with it, someone else can come along, understand it, and effect a repair. And I guess rounding that out is, let's say for example, if you had a problem mechanically with a Model 3 drive unit, let's say you put so much power into it, it blows the diff casing apart, or shears off a motor shaft, or does something like that, you can take that PCB out, stick it in another drive unit that you get from the scrapyard, and drive back on down the road. So that's kind of a very long-winded version of just responding to that comment. So secondly then, I've been asked in a few places now about this, whether the actual KiCad source for this is going to be made open and available. I can definitely tell you at this point, in this very early development stage, no, it's not. Because it's too easy to get muddled up and confused here, because this is quite a reverse engineering project. Perhaps in the future it will be, but that's yet to be determined. There is, however, a lot of information on the GitHub repo, and I will put a PDF of the schematic that we have here up there later on today for you. So by the time you're watching this video, you can go to that link in the description, go to the GitHub repo, and you'll see what we have so far. Primary focus is on the gate driver part at the minute and getting that worked out. So just rolling back up through some of the comments then and questions that I get asked. It kind of ties back in a little bit to the first one, is, well, if I'm not going to use the Tesla software, well then I can't really expect to get the motor to run, it's not going to really work well, etc. So I'm not going to get into that, folks. It's just I'd be here again for another 20 minutes at least talking to you. What I will do, so there'll be a link in the description to the Open Inverter wiki start page. I'd advise anyone that's not familiar with the Open Inverter project, spend some time looking around there, and you will see that there's a plethora of motors running throughout the world with the Open Inverter code base, including Tesla motors. So let's see, what else did I want to address for you. Let's just have a quick look so I don't forget. Okay, so I just had a quick look there because there was two other comments I wanted to address. The first one was, is the TI microcontroller software project open source? It certainly is, and I'll put a link in the description to that project as well. Currently we have one gentleman in the UK working on that. So we've got a kind of a multi-pronged attack, but for anyone interested in using the existing board with TI micro and Open Inverter firmware on it, there I'll put a link in the description to that. Alright, and the last one is actually more of an observation rather than a question. And I didn't know this personally, but it looks as if quite a lot of the Tesla vehicles are now using this inverter form factor, including the plaids and all this kind of thing. I don't keep up with that stuff, sorry folks, but yeah, so it looks as if there's quite a wide variety of drive units available that this PCB will potentially fit. I know, for example, just because I happen to have them, it will most definitely do both the front and the rear Model 3 drive units. It'll be just a slightly different software running on the microcontroller. So, okay, that's enough of me talking out. Let's have a very quick look here, because I don't want to keep you folks hanging around too long. I know you have funny cat videos to watch. I do too. So obviously since we last spoke, the PCB has filled out quite a bit, and most importantly is if we now flip the board over, which we can do, you'll see that there are now no components, and I can scroll my stupid head out of the way. There are now no components on the back of the PCB around the gate driver section. So Arthur has successfully made this now a single side surface mount board, which was more than our Musco friends were able to manage. By the way, I will put a link to Arthur's YouTube channel in the description as well. I strongly recommend checking that out. And you can like and subscribe to his videos though, just not mine. So, obviously I didn't spot this the last time, but some of the more eagle-eyed amongst you may have. What you'll see is a rather bit of a change to the flag here, but you know, they're both, I think we've got the important bits of both of them here. Anyway, now that we've that out of the way, yeah, so our board has filled out nicely. We now have, I believe, all the components for the high voltage side of the gate driver laid out. As I said, single side surface mount now, unlike the Musco. And here you will also see, if we do a bit of a zoom in here, you will also see that we have started on the logic side of our gate driver chips. So the SPI and the interconnection, I believe Arthur has now done. Where's my schematic? Yes, he has. So this is our schematic at the minute. We just have our gate driver hanging around here. I won't do too much detail on this, but as I said, I will take a PDF of this because there were some comments of people making some very useful suggestions here, and although I haven't replied to them, I will definitely be reading them and referencing back to the schematics here, so thank you very much to the folks who took the time in the last video to have a look at that and comment on it. So for your info and for other people, as I said, I'll put this schematic as it stands today, which is the 15th of August 2024, up on the GitHub repo for you to see. So we've still got some components to ID, but it is beginning to definitely fill out with all three phases here schematiced up, as it were. So as I said, I won't get into this because for those that want it, I'll put it on GitHub for you. So let's have a quick look at the actual PCB layout. Now this is the next part where we're going to be having some fun, and I personally may be having some fun myself with this. So if we have a look at our PCB layout here, you'll see that what we've done so far, or I should say what Arthur has done, I'm putting we as kind of a more of a just a catch-all phrase. I'm not really trying to, you know, say that I did any of this. I certainly didn't. So the component placement is pretty much, as I said before, exactly where Tesla have it. But we've managed to flip those parts that they had on the back of the PCB up onto the top. Now, this is a multi-layer board, okay? And it's not, I think I mentioned this in the last video as well, it's not like we've just done a full plane here like this, like we normally would, and say put a ground plane over the whole board and like a 5-volt plane or anything else over the whole board. It's broken up into various sections, and the layers, signals travel from one layer to the next and so on here, because this is a mixed board between the power stage, the high voltage bus, discharging stage, line derived power supply as I tend to call it. It's just a Viper 20, it's nothing fancy. Then we've got our gate driver power supply here, and our finally kind of logic section here. So it's quite a mixed PCB. So while we can kind of probe around here and use just light behind the board, as well as you will see has been done here to kind of give us a better idea as to where the various layers and tracks go. The good news is that one of my crazy patrons has offered to do some CT scanning, some X-ray CT scanning on this. Don't know much about that myself, but it's going to be very interesting to see a CT scan of the layers of a Model 3 drive unit board. Now, if that doesn't work out, let's just say that we may have to take a more, as Mike's Electric Stuff would say, a more of an applied violence approach to this, and that'll be my specialty. Where I will get medieval on one of these boards with a belt sander and a pair of pliers, and we'll basically do it the hard way, and we will peel the PCB apart and find out where the various traces go. Let's hope we don't have to go into that, but if we do, I'll certainly video it for you because it'll be quite interesting. So what I'm going to try and do this coming week now is I'll finally be finishing up working on the house, hopefully, is I'm going to attack the power supply stage here, and we're going to come up with a way of providing our 4 isolated supplies for our gate drivers. Might even, I have vague recollection that that transformer is an off-the-shelf part, so I'll have to look that up. It's a TDK part. Yeah, I think I looked at this before. I just have a vague memory that that is a available part, so I'll see if I can hunt that down, because it'd be nice to use the same transformer, because we know that that would actually work for us. So that'll be what I'll be doing, and we will then have our 2 microcontrollers on here, and I'll be trying to do some layout around this part and actually contribute something rather than just these stupid videos. So that's about it really, folks. I just wanted to, as I said, just respond to some of the comments and give you a little update here, because I find this amazing to look at. I just find that amazing to look at. It's like one of these sci-fi movies where there's some alien artifact, and you know, it's kind of, you just go, when your brain gets completely emptied and refilled with some alien programming or something, like, yes, Tesla good, Elon good, must follow, drive Tesla only, something like that. Anyway, I'll try not to let that happen to me, but no guarantees there. So yes, I'm going to be getting on with this, hopefully, and we'll be back to you with another equally boring episode. And there'll probably be more stuff here, hopefully. So folks, yeah, thanks very much for the support with this. Thanks very much to Arthur for coming on board with this. It's just been an amazing injection of energy into the project for me. So I'm really keen to get back in on this and to actually see it starting to come together. One question for you folks, I know some of you might know, but I'm willing to bet this is the first time that a Model 3 drive unit PCB design has started to appear in KiCad format, because I somehow doubt that the mothership used KiCad, but correct me if I'm wrong. Anyway, video is already getting long, folks, so sorry for all the ranting, but I am very excited about this project now. So right, I'm gonna sign off. Usual applies. Don't forget to give this a dislike, thumbs down. Do not subscribe to this stupid channel. Whatever you do, do not support me financially on Patreon or PayPal or any of those other links that you might find in the description, because they're stupid. Because then I'm gonna take your money, I'm gonna spend it on getting boards made, and then I'm going to retire to Lanzarote. Who wants that? So, do however check out the links to the Open Inverter wiki start page. I'll put in there for people that are interested in it. I'll also have links in there for the hardware and software side of the project to make an open source ecosystem around the Model 3 and various other vehicles now that are using this design of board. So folks, thanks again. We will, as I said, see you next time, and until then, happy layer peeling.